So look at the question first. We have to rewrite example 11.2, but the difference is in example 2, we had equal high portion and low portion. But in this case, that is the only difference. Now we need to have a high portion of 1085 microsecond and a low portion of 15 microsecond. And the connected oscillator is also changed. The crystal frequency for this problem is 11.0592 megahertz. So let me give the solution first. After that, I'll discuss it. Most probably you don't need to write if it is the exact same example in your book. So then I don't think it is needed to write. So this is your code. Okay, let me go line by line. Origin 00, nothing to explain over there. Then we long jump main. So we come over here. Then we move 10H to T mode. This is done in order to use timer 1 in mode 1. So this is from your chapter 9. So to use timer 1 mode 1, the value which is to be loaded in T mode is 10 hex. Then we load the value 0188 and 0f8 H is these two numbers are based on this amount of delay. Again, this is something that we saw in our previous class. Also, we discussed in details in chapter 9. So I will not discuss that again. But for this amount of delay, the value which is to be loaded in timer 1 for mode 1 are this. Then we load the value 88H in the IE register because we need to enable the EA bit of the IE register. At the same time, we need to enable the timer 1 interrupt. So for doing these two things, the value which is to be loaded in IE register is 88H. Then we start the timer by set bit TR1. So we know that set bit TR1 will start the timer. After that, we enter in this loop and we remain in this loop indefinitely. This is what happened in 11.2 in our last example, in our previous class. Fine. So since we have started the timer, your TF1 is responsible for invoking the interrupt or for activating the interrupt. Whenever the value of TF1 becomes 1, it initiates timer 0 interrupt. So what does that mean? Initiating timer 0 interrupt means your MUSE will directly jump to 001BH. And from where we get this address? We get this address from the interrupt vector table. So whenever your timer 1 interrupt is invoked by your TF1, then your MUSE will jump to 001BH. That means it will come over here. From here, it will see the instruction long jump ISR underscore T1. So it will look for this level and it will come over here. First of all, what it will do, it will stop the timer. All right. Then it will clear P2.1. Now, there is something that you need to understand in this line, because when reset, when your MUSE is reset, all our pins are high. So that means P2.1 will also be high and it will remain high. In this particular line, you will clear your P2.1. That means from high, it will go low. But before coming to this line, how much time did you spend or how much time has elapsed? So you see, we loaded these two values in our timer 1 because we wanted this amount of delay. That means by the time we come over here, we have passed at least around 1085 microseconds, which is the duration of your upper cycle, upper portion. Then you clear P2.1. After that, we move the value 4 to R2. All right. See, by this time we are still in our lower half. So let's see how long is our lower portion. So this is from where our lower portion starts. Then this line is also responsible. It will run for 4 times. Again, we load the values in TL1 and TH1. Again, we start the timer and we let it get back to high. So again, it goes high in this particular line. So before this line, all the instructions which were executed, if you count the machine cycle of these instructions, you will see that these machine cycles altogether need approximately 15 microseconds time to come from this line to this line. So from this line to come in this line, it takes around 15 microseconds, and this is the portion during which your P2.1 was cleared or it was low. That means over here you have got approximately 15 microseconds. After that, your P2.1 is again sent back to high and you return I. That means you come back over here in this back loop. Again, you will remain in this back loop until and unless TF becomes 1. So again, you will get back over here. Again, you will long jump. So you will repeat on, you will keep on doing these things. So you will keep on getting a high portion of 1085 microseconds and a low portion of 15 microseconds. All right, so that's your example 11.3. If there is any question from your side, you can ask now.
Why did we use 2 times the duration?
Is there anyone saying something? I can't hear anything. কেউ কি কিছু
Yes,
বলতেছে?
sir. Yes, sir. Can't you hear us?
Just a second, just a second. I think I need to adjust my speaker. Just a second. Can you speak again? Let's see.
Can you hear me?
Yeah. Now I can hear you. Thank you. Sorry, it was a problem from my end. Okay. Yeah. Say.
Sir, why did we use two loops for the high pulse?
Why did we use two loops for the?
High pulse.
Did we use two loops?
Sir, once we used it for the, why did we 018 and the 0FCH? Why did we do that?
Okay, I got the question now. So this is your mode 1. Okay, in our example 11.2 we used mode 2 where we need to put the value only in the TH1 or TH0. I mean only in the high portion of your timer. But in mode 1 is our 16-bit timer. So in 16-bit timer we need to load the values both in TL and TH. You can just review chapter 9. Okay, you will get your answer from there. If whatever I said is not clear, you can review chapter 9 once again. Okay.
Sir, why are we moving Y and N into P0 and P2?
This is from your example 11.2. That was the task which was asked in example 11.2 to continuously move the value Y to port 0 and N to port 2.
Oh, yes, sir.
Okay. Any other question?
The main loop is for the high pulse, right?
Not necessarily, because once you have started the main loop, then once you have entered the back loop, you will never go to the main loop again. So yeah, you can say the main loop started the high pulse, but from that point onwards, your ISR underscore T1, this loop controls both your high and low pulse. Right?
At the end of the code, set the P2.1 to high, then it will remain high forever.
No. It will not remain. See, just before setting P2.1 to high, your last instruction was set bit TR1, right? That means you started timer 1, right? So once again, timer 1 will finish. Again, you will go back. I mean, that interrupt will be invoked. Again, it will be cleared. So you will keep on getting the output that I just showed in P2.1, this portion. You will keep on getting this output.
How did we calculate the 1085 microsecond for the high partition? হাই পালসের যে 1085 মাইক্রোসেকেন্ড ডিলেটা সেটা আমরা কিভাবে ক্যালকুলেট করছি?
এই জন্য বলি চ্যাপ্টার আগের চ্যাপ্টারগুলো ভালোভাবে পড়ে আসতে। In chapter 9 there was a question, I mean there was a definite article that for creating a specific time delay, what are the values to be loaded in the timer registers? You review that portion again. Okay, that is completely in chapter 9. We had, I think, 1 class dedicated for this portion. So see those calculations.
আমার প্রশ্নটা ছিল স্যার, মানে জাস্ট ওই TL1 আর TH1 এর ভ্যালুটা ক্যালকুলেট করেই কি 1085 এর যে লাইন লস?
হ্যাঁ, exactly, because this 1085 directly gives you the delay. It is not related to frequency or duty cycle or anything else. This is directly the delay that you need to generate. So once you are given the delay, see over here, this is directly your delay. So once you have the delay, you can directly generate that. Okay, any other question? Yeah, so if there is no other question, then let's move on. Alright, so let us now discuss about the external hardware interrupts. Mm, All these points are actually pretty self-explanatory. Okay, let's just overview. So there are two external hardware interrupts. One is interrupt 0 and the another is interrupt 1. There are two ways by which you can activate these interrupts. One of the way is known as level triggered and another way is edge triggered. So these are the two ways by which you can activate, enable or not enable, by which you can activate or invoke or trigger an interrupt. Okay, so these are the two ways. So let us discuss the level triggered interrupt first. So normally our both the interrupts are high. So interrupt is triggered if a low level signal is applied. All right. So as we said, normally the interrupts are high. If a low level signal is applied and something like this, then the interrupt is triggered or activated. So normally they are high, we apply a low level signal. Fine. So it is also called level activated interrupt. This is just the other name. And this is the default mode upon reset of your 8051. That is by default, your level triggered interrupts are enabled. Now, the last point you need to understand, okay, this portion. It says that the low level signal at the interrupt pin must be removed before return I. So what does this mean? So you see the interrupts are normally high. Once it goes low, that means the interrupt is enabled. So enabling the interrupt means it will go to a particular address. I think one of the address of this uh, external interrupt is 00038. Okay. So whenever you apply a low level signal, your MUSI will directly jump over here. It will execute the instructions which are there until and unless it encounters return I. Assume that to execute all these instructions, you need a time of a second or a microsecond, whatever you say. And the duration during which you applied this low signal is b microsecond. The last point says that this b microsecond should always be less than a. That means by the time you come to this return, this signal must be returned to high. That is what it says. The low level signal at the interrupt pin must be removed. That is, it must be set to high before return I. So before you execute return I, we have to make sure that this one goes high. That's why I said that if it takes a microsecond, then your low level signal should be applied for b microseconds such that b is always less than a. So is it understood to all of you? Have you understood?
Yes.
Yeah. So now let us take an example. Oh, another thing is that, I mean, this is what what I just say, that this portion low level signal should be less than B. This is not something that you can control. Okay, this is controlled by the designer itself, and normally your B is approximately 4 machine cycle based on the connected crystal. This time will change. You know that because machine cycles depends on the connected crystal, but normally B or this low level signal is applied for 4 machine cycles. before going to the solution, let us just overview the problem. So it says that two switches are connected to the pins P3.2 and P3.3. You can check from the vector table, interrupt vector table, that these two pins are responsible for activating your external hardware interrupt 0 and interrupt 1. Now, when a switch is pressed, the corresponding line goes low. This is where it is specified that it is a level triggered interrupt, because in level triggered interrupt, the corresponding line goes low if a switch is pressed, or whenever we have a low signal in the particular pins, the interrupts are activated. Okay, so the question says light all LEDs connected to P0 if the first switch is pressed, and light all LEDs connected to P2 if the second switch is pressed. This is actually very easy. Probably this is the easiest example in this chapter. So let me write the code. After that, I will explain. All right, so this is the code. Let me just go quickly line by line. So we start with 0, 0, then we long jump main, we come over here, we move the value 85H. Why we move the value 85H? Because we are enabling the external interrupt 0 and external interrupt 1. And we know that the the EA bit of the IE register must always be 1. So to enable these 3 bits of the IE register, the value that we need to move to the IE register is 85H. Then we go to this here loop and we stay over here indefinitely. Actually, you can engage your music to do any work over here in this loop. I mean, the question does not say of any work. That's why your music keeps on polling over here or staying in this loop indefinitely. But that is not needed. You can engage your music to do any other work. Okay, so whenever the first switch is pressed, assume someone just pressed the first switch. So if someone presses the first switch, then the corresponding line goes low and your interrupt 0 or external hardware interrupt 0 is invoked. So what happens if the external hardware interrupt. So if interrupt 0 is invoked, your MUC will directly jump to 0003H. So your music comes over here. Then it lights all the LEDs which are connected. And then it moves some value to R0. It stays in this loop for some particular period of time. Again, it returns. Again, it is over here, short jump. Again, if suddenly someone presses pin P3.3, then your interrupt 1 is invoked. So that means it will directly go to address 0013. So it will come in this particular address. It will do the same thing, and again it will return. So that's it. It is a very simple code. Okay, if there is any confusion or any question, please do ask.
And how did we understand that the duration was over before RETI?
Okay, the duration of low level signal was over before RETI, right? This is what you are asking.
Yes, sir. Yes.
As I said, from the program or from these codes, you cannot understand. It was created when the device was designed, when your MUC was designed. See, this line says the corresponding line goes low. So whenever someone says this thing, they need to architecture it within the device, right? So whenever they designed those devices, they made sure that this low signal will be over before return I is reached. Also, at the same time, from your point of view or from the programmer's point of view, what we did is we initiated another loop over here for some significant amount of machine cycle time, so that we provide sufficient amount of time for that low signal to go up. Is it okay now?
Yes.
Any other question?
Sir,
Sir,
the 255,
বুঝি নাই।
sir, the 255 is the arbitrary value, right?
Yeah, it is arbitrary, definitely arbitrary. আরেকজন কি জানে বলতেছে তা?
Sir, the switch that is being pressed, isn't it external switch connected
Yes.
to some port?
Yes, it is external switch which is connected to port pin 3.2 here and 3.3. So these are the switches.
Yes, sir. So these switches are supposed to be pulled up switches, right? Pulled up to high. So if I press it and keep it low for like maybe 1 second, then the code won't work, isn't it?
I mean, do মানে কি like চেপে ধরে থাকো এরকম something like that.
Yes, sir.
Okay, so you're talking about something, it goes again, like how the switch is designed, whether you can keep on pressing it, something, I don't know about that. So it will depend on the architecture or fabrication.
Sir, in that case, can we do it like this? That will monitor P in the in the line LED 1 and LED 2. We can keep
Yeah,
it.
I got your point. You will keep on polling that whether it goes high or not, right? So once it
Yes,
goes
sir.
high, yeah, you can do that. That is even, I mean, you are talking about a safety precaution, right? So you can do that.
Yes, sir. Okay, thank you.
Any other question?
Is the book example of
আরেকবার বলো,
like the
wait.
Sorry.
কেটে কেটে আসছে, আরেকবার বলো তো কখন থেকে?
Sir, now is it clear?
It is clear.
Sir, is that example like the book's example 11.5? Like in my book, the label LED 1 and LED 2 have started from
ওইটা
the
একটু
line
ভুল আসছে। হ্যাঁ, বুঝছি, I got your question. In the book, the labels are misplaced slightly, okay? The labels are supposed to be where I just wrote.
Okay, sir.
Any other question?
আর দুইটা চাপ ধরে থাকলে কি হবে?
হ্যাঁ, বুঝি নাই কি?
দুইটা একসাথে চাপ দিলে কি হবে?
আচ্ছা, I will answer this question in a little bit. Any other question? Okay, if there is no other question, let me move on. I'll give your answer, don't worry. Now let me come to the best part, okay? That is, I will leave something for self-study. Okay, so your self-study is Okay, so your question, you will get the answer over here. Okay, I mean, it will have some priority list. So according to the priority, if both interrupts are pressed, whichever has got the higher priority, that will be executed first. Okay. So those are for your self-study, and there are few things from this chapter that you can exclude. They are section 11.4 and section 11.6. And with this, our chapter 11 comes to an end. So if there is any question, you can ask now. Any question on this chapter or anything related so far? Okay. So if you do not have any question, let me just take your attendance. After that, you are free to leave.